Alright, Algebra 2 class, hold on to your hat. Today we're going to apply the law of sines for the SSA case. So everything I've written in a thinking bubble does not need to be written on your paperwork. It's background, it's explanation for what we're doing. There is a lot of complexity to this, so stay tuned. Make sure you watch this in its entirety so you can have an idea of how to find the 0, 1, or 2 triangles that are possible in an SSA case. There are several possibilities when solving an SSA triangle. Remember, you cannot prove two triangles are congruent who share the same SSA. Therefore, when solving an SSA triangle, there are 0, 1, or 2 triangles possible as follows. So let's take a look at our situation 1. Given SSA, if angle A is an obtuse angle, there are going to be two possibilities. Either you will be able to form one triangle or no triangle at all. Okay, so how can we tell which situation is which? Well, if you have an obtuse angle that you're given in an SSA triangle, and this side next angle A, the B side, if that side is in fact less than A, or if, in other words, A is greater than B, you will be able to form one triangle, and you'll be able to give the measurements for that one triangle. If this side A is too short, and it is less than or equal to B, it's too short and it can't actually, no matter how you pitch the angle here, no matter how big or small you make it, it doesn't reach down to this length here that is not given to us. But no matter how you try to stretch it, it actually won't connect. Then there will be no triangle. And we'll work together in a minute to see how we decide if there's one triangle or no triangle in this situation. Situation 2, if your angle in the SSA triangle is acute, there's actually more possibilities. There could be no triangle at all. There could be two triangles, or there could be one triangle. It could be any one of these cases, and our work will actually be able to determine which situation it is. And if there are two triangles, we'll be able to name all the angle and side measurements in the two triangles. If there's only one triangle, we'll be able to give the missing angle and side measurements as well. Okay, so I want you to pay particular attention to if there's two triangles. How is that possible given this one angle and a side we're going to call B and a side measurement called A? Well, imagine first that we were able to form a triangle with A and B sides with this acute angle. What happens if it worked out just to be the case that we could swing this side A over so that it actually fit right in here, and so this side becomes shorter than it was originally, but it still would make a triangle, A, B, and angle A. So that's a possibility. So this A, if it's a situation where it's just right, we could swing this side A over and it could make a second triangle. All right, so let's go and work some of these out to see how this works. Example 2, side angle with one solution. Okay, so we're given these measurements. I go ahead and draw the triangle. I'm going to go ahead and draw angle A so it looks like it's more than 90 degrees to get a good visual on this. So I'm marking, what do I know? 115 degrees, B is 11, and A is 20. Okay, that's given information here. All right, remember your A side has to be opposite that A, and so I've marked it in the way it needs to be. So this is A is equal to 20. It has to be opposite angle A. And our B length, the side of the triangle that is B, has to be opposite our B angle, and C has to be opposite our C angle. Always, always, always. So these are the three things we're trying to determine. What is angle C, what is angle B, and what is the length of C? So let's see if we get a triangle. We're going to use our law of sines that we already know about to solve for one possible triangle. All right, so we're going to take the sine of A, 115 degrees, over side A, 20, and that's equal to the sine of B, and I'm going to call that B1 because it's the first possible angle in possibly two triangles. So that's how I'm going to notate. When I'm looking for my first possible triangle, I'll give my unknown measurements a subscript of 1. That will distinguish it from possible angle and side measurements for a second triangle, which I will use the subscript of 2 for. All right, so there's my sine of B sub 1 over my side B, which is 11. And we've done this before, so I'm going to use my cross products here. 20 times the sine of B1 equals 11 times the sine of 115 degrees. And then I'm going to divide both sides by 20, and that's going to give me sine of B1, and here it is on my calculator. I keyed in 11 times sine of 115 degrees divided by 20, and this is what it gave me. A lot of numbers on my display. Then I'm going to write the inverse of this function because I want to know what my angle B1 is. I need to be solved for B1. So I write sine inverse of, when we switch the number and the angle, and that's going to give me my B1. Sine inverse of 0.49846, that's equal to B1. If you leave this number in your calculator and then you just do the inverse of that number for sine, that will be the most accurate. You also could just round off to 0.498 and find sine inverse of that number, and that will give you the angle measurement 29.8987 degrees, so I round that off to 29.89. Okay, so I found what my B1 could be. Now let's go ahead and figure out my C1. So all three angles must add to 180, so my known angle of 115 for A, plus my B1, plus I don't know for my C1 is 180, and I solve for C1, and that gives me 35.11 degrees. Okay, that's great. Now I use my law of sines again to find out my unknown length C1. So that is sine of C, which is 35.11 degrees, I pull it right from here, over C1, is equal to sine A over A. We've already seen that above. And then I'm going to solve for C1. So C1 times my sine of 115 degrees, using our cross products, equals 20 times the sine of 35.11. C1 then is going to be whatever my calculator tells me all this is. It tells me it's 12.6921, which I round off to 12.69. Okay, so I've solved my first triangle. I know my C1, I know my angle C1, I know my side length C1, and I know my B1. Those are the unknown measurements. But it is possible that there is a second triangle, so how do we find it? Well, there are two values for sine for this angle 29.89. When we find the sine of this, there are actually two possibilities, and here's a picture of it. Now, I've just used 29 degrees instead of 29.89 just to make it easy for you to visualize what's going on. For sine, remember in quadrant 1, sine is positive. Sine is also positive in quadrant 2 because it's y over r, and in both cases, y over r would be the same. So we have a reference angle here of 29 degrees that will give you the same answer as the sine of 29 degrees in quadrant 1. So we have to consider what happens if we wanted to know the sine of the reference angle 29 degrees here in the second quadrant. So we would find the standard position angle for the second quadrant with the reference angle of 29 by subtracting 180 minus 29. And that's what I'm doing here, except I'm subtracting 29.89, the actual degree measurement. So 29.89 plus B2 is 180, or 180 minus 29.89 gives me another possible angle measurement for B2 because it also has the same sine as 29.89. Both 150.11 when you take the sine of that angle and when you take the sine of 29.89 give you exactly the same answer. So let's see if this is a possibility. Well, if it's possible, then when you add all three of the angles inside of this triangle, they'll sum to 180. But look what happens in this case. When we add this possible angle, B2, 150.11 degrees, plus the known angle, 115 degrees, we get an answer greater than 180 degrees. Two of the angles are already summing together to be more than 180. So that means in this case, this second angle doesn't work. We throw it out, and there's only one triangle possible then. But this is how we determine if there's a second triangle. We find the other possible measurement for the angle that we were determining in our first triangle, and we find the supplement of that angle, and we then see if that is possible that there could be another triangle formed. If this angle actually worked, then we would find angle C, and then we would find the unknown side length C as well. All right, so we only have one triangle in the situation, and we boxed up all of the measurements for that one triangle. So we'll move on now into example 3. But I want to actually point out one thing that we haven't really talked about yet. All right, so let me go back here. Since your given angle A in your SSA triangle was obtuse, there actually were only two possibilities, no triangle or one triangle. Since two triangles are not possible given an obtuse angle in SSA, in this case you really don't have to check for the possibility that there is a second triangle because you already know there isn't one. But we're going through the procedure just so you know how it works, that we're always looking for a second angle once we've determined a first angle measurement. But when we're going to move into this in an example in a few minutes, if you're given angle A and your SS triangle is acute, which it wasn't in this case, but if it were acute, you do have to check for a second triangle if one triangle is possible. We'll practice that in example 4. All right, example 3, we're going to get no solution in this case. We're going to try to solve this triangle and it won't be possible. What I've drawn here actually it can't be true. How do we do it? Well, we're going to use our law of sines. So I'm going to do sine of A over A, that's sine of 51 over 3.5, is equal to sine of B1. I'm going to label that B1 in case there's a possible second angle that also would work for B. So sine of B1, which we don't know, over 5. I'm going to use my cross products to find my B. So 3.5 times the sine of B is 5 times sine of 51 degrees. Divide both sides by 3.5, so sine of B is 5 times sine of 51 over 3.5. Throw that into your calculator, and this is what you're going to see. All right, so now it's time to say, well, let's go ahead and find sine inverse of this angle. So switch the 1.1 and the B1, and you use your inverse function. And your calculator is going to tell you that it can't do it. It's going to give you an error message because the domain of the inverse sine function is between -1 and 1. 1.11 is actually outside of that domain. It's not between -1 and 1. So it is impossible to find angle B whose sine value is 1.11. There is no angle possible. So no triangle, no solution. And that's how you're going to find out that you have a no solution situation. You're going to set about the procedure of using the law of sines, and when you go to find that angle measurement, you're going to get an error message on your calculator. No angle will be possible. So when that happens, no triangle, no solution. So if you get an answer to the sine of the angle that you are trying to find, if it is outside of -1 and 1, if it's either greater than 1 or it's less than -1, then you know there's no angle possible. All right, what about our two solution situation? Okay, so let's step through this situation. We're solving this triangle, and there are going to be two solutions, and I have drawn a picture of what those two solutions are going to look like. We have an acute angle, 40 degrees. Anytime you're in an SSA triangle situation, you have an acute angle. There are possibly 0, 1, or 2 triangles that can be made. So in this case, my A is actually going to be able to swing around here, and we're going to have a shorter AB for our second triangle than in the first triangle. And we're also going to have different angle measurements for our C angle, which we're going to call C1 and C2. We're going to have different length measurements for our AB length here, our C1 and our C2. A is 13 will stay the same, B is 16 will stay the same, and our angle A will stay the same at 40 degrees because those are givens. All right, let's step through it. Sine of A over A, sine of 40 degrees over 13 is equal to sine of B that we don't know yet over 16. We're given the fact that the side opposite angle B is 16. All right, let's solve it and see what we get. So cross products, sine of B1 times 13 equals 16 times the sine of 40 degrees. Divide both sides by 13. Sine of B1 is equal to 16 times sine of 40 degrees over 13. Throw all that in your calculator, and you will get this on your display, 0.791123. You're going to find that angle measurement by doing sine inverse of that number. That's going to give you your angle B. So sine inverse of 0.791123 will give you an angle measurement of 52.29. Now I'm going to leave this in my calculator, this number, and I'm going to use that to find my sine inverse. If you round it off, that's okay. It won't be quite as accurate, but it'll be close. All right, so I got a measurement for my angle B. So now I find my angle C. All three angles will add to 180. I have two known angles, 40 and 52.29 for my A and B. And I'm going to solve for C, and that's going to give me 87.71 degrees. All right, I know my two angles in my first triangle. And now I'm going to find that unknown C1 length opposite my angle C1. I'm going to use my law of sines again. Sine of A, 40 degrees, over A, 13, is equal to sine of B, 87.71. That's what I just figured out, over my C1. Cross products will give me C1 equals sine of 40 equals 13 times sine of 87.71. Divide both sides by sine of 40, and you'll have 13 times sine of 87.71 over sine of 40. Throw that into your calculator, and you'll see 20.2082, and it will continue on. Round that off to 20.21 for your C1 length measurement. So we have our first triangle all figured out. We have our length measurement C1. We have our angle measurement 87.71. We have B1 52.29 degrees. What about the other possible angle for B? Well, our B2 could be 180 minus 52.29. You can always find that other possible angle measurement by taking whatever you got for your first angle here, subtracting it off from 180, and that'll give you another possible angle measurement. Last time, this second angle measurement didn't work, but this time it will work because when we add our known angle of A, 40 degrees, our B2 angle, 127.71, plus our C2, and make that equal to 180, we will find out that it is possible that C2 would be 12.29 degrees. These two do not sum to more than 180, leaving room for our C2 angle. It's a small angle, but it still works. Okay, so what's our next step? Well, we have our B2 angle and our C2 angle. So our last step for our second triangle is to find the length of C2. How long is it from A to B? What is our C2? Use our law of sines. Sine of A, 40 degrees, over A, 13, is equal to sine of C2, which we just figured out here, 12.29 degrees, over C2. That's our length measurement of our short side of our triangle. Cross products gives us C2 times sine of 40 degrees equals 13 times sine of 12.29 degrees. Divide both sides by the sine of 40 degrees, and C2 is equal to, well, throw all that in your calculator, and you have 4.30496, and that rounds off to 4.30. So we have two different triangle measurements. So our second triangle has angles B and C, 127.71 and 12.29 degrees, and our length of C2 is 4.30. So we get different measurements. So in this case, there are two triangles possible. We found all of the unknown measurements in both of them, so that completes this particular problem. So a lot of detail to be attended to when you have two triangles. So when you are continuing now in your homework, you are going to solve each problem, assuming that there could be up to two triangles possible. Sometimes you'll get lucky, and I think there's only one problem where you're going to get no triangle in your homework. And so that will resolve pretty quickly. Then there will be one problem where you will find that there is one triangle, and you'll find all the measurements for that one triangle. And there'll be a couple of problems where there will be two triangles possible, and you will need to find the measurements of both of those triangles. So they will have as much detail as this example that we just went through. Okay, so you only have 4 problems to do on your own. It's time to move into your homework using this set of guided practice problems to assist you in working through them. Please make sure you stop in at a Zoom session if you need further clarification. We'll see you next time.